So here we go. We're coming back to solving quadratic functions. And what does solving mean? Right? Then we have to backtrack a little bit more even. Solving means finding the x-intercepts, which also refers to the roots, which is the same thing as the zeros. And notice that for all of these, one thing is true, y is equal to 0, right? Like that is something that we should just know that, right? When we find the x-intercept, y is equal to 0. Okay, so that's important to note. There are two methods of solving quadratics. There is actually a third one, which is factoring. Don't you love factoring from IPR? You remember factoring?
Yeah.
You probably hated it, right? You're not going to have to factor. Even if the textbook says use factoring to find the x-intercepts or to solve, you're going to just not listen to that and just use your calculator or the quadratic formula to do that, okay? I give you permission to do that. So don't worry about, so the third one is not, I'm not going to cover it because it's not necessary for, we don't need it. That's a pre-cal thing. All right, so if it's in standard form, we have our A, B, and C values, which could be positive or negative, and we use this formula to the letter, okay? You use it exactly the way it is to come up with your roots. The highlighted part is called the discriminant, which if negative, you have to state there will be no x-intercepts. And why is that? Parabola does not cross the x-axis, right? That's why it is, right? Essentially, visually, it's because the parabola doesn't cross the x-axis. If it is positive, so anything that's bigger than 0, you're going to have two x-intercepts. If it's exactly 0, of course, only one x-intercept. Okay. So, and I asked you to do the textbook questions. I hope you did practice that. A question like this is normally worth 2 to 3 marks, depending on how much work is involved. And it's easy 2 to 3 marks if you know what you're doing. A lot of times it's just not paying close attention to the formula, not copying it down the right way. I see a lot of students doing, I'm going to take a sticky or something. One common mistake I see is students having it like this. Like they just have the 2A under the B for some reason. For some reason, this line that I clearly make sure goes from end to end, all of a sudden it's just here, right here, and it doesn't make it all the way through. The 2A is going to divide everything that's on top, okay? So you got to make sure, right, you move this to the middle right here and say, okay, whatever happens at the top, I'm going to divide it by 2 times A, okay? Very common mistake. So just watch out for that. Another very common mistake is for some reason students getting these signs here, forgetting that ultimately this whole thing will be negative. Combined with this negative, that turns into a positive, okay? So you got to watch out for that. All right, so we'll do a couple more, a bit more challenging questions today. This is the homework that I'm going to assign to you. So let's write it down first. Let's have it down so I don't forget. And I selected a few that there are going to be word problems, okay? This is a nice review. Do you know how to do word problems, right? Do you know what is asked of you? So page 428, question 4 is you use quadratic formula and graphing, which we're going to talk about today. 6 to 10 is just word problems. 11 is very challenging. That would be a bonus question on a test. So if you like that kind of challenge, I threw it in there. Okay. There won't really be an example that I would have done on that. So it can be done using regressions though. It can be if you know what you're doing. And I say clearly, don't tell me I didn't tell you, no factoring, use calculator. So if one of these questions says use factoring or factor this to find the x-intercepts, don't listen to it, okay? Just use your calculator like we've done before. Okay? Okay, so write this down, and we're going to solve each one of these examples here. And if you didn't catch it, I did return the quizzes earlier, so you should be able to see. And I will post the answer key as well. Are we good? It's down. Okay. So we'll do A first here. And it says to use a quadratic formula, so you don't have a choice. Okay. So what we will do is rewrite equation into standard form. Okay. That's what you want to be doing when it's something, when there are terms on either side of the equation, you want to bring everything over to one side. I always bring everything over to the left side. That's just how I do it. It's really up to you, right? So if you think about it, I start with a 2x squared and I look for the x squared term on this side and it's 5, right? So when it comes over, it changes signs. So it'd be negative 5x squared. Then I copy down what's already there, which is the x term plus 3x. I look on the other side, there's an x term there, and it's 7 positive, so it will come over negative. And the negative 4 will come over positive. So I think I will just say that, right? I'll just highlight that this came over, this came over, and this came over. Okay. Move everything to one side. Switch signs. Okay, that's very important to remember. Switch signs when you bring stuff over. and then you combine like terms. So 2x squared minus 5x squared, that'd be negative 3x squared. Plus 3 minus 7, that'd be negative 4x. Plus 4. That equals to 0. Okay. And now it's basically the way you did everything else. So a is equal to negative 3. B is equal to negative 4. C is equal to 4. It would not matter. Your A, B, and C will have the exact opposite signs, right? But when you plug it in and you solve it, it'll be the same final answer. Yeah. Yeah, so it doesn't matter if you bring everything over to the right, whatever works, okay? So then we start with our equation, right? So it's negative B. So notice that B is negative, so you make sure that there's a double negative. This one is there from the formula. This is from the actual value, right? Plus or minus square root of B squared minus 4 times A times C, all over 2 times A. Then it's 4 positive plus or minus. And this, if you're careful when you use your calculator, you can actually just type it in one shot. Right, so we'll make that appear here. Okay, so it'll be negative 4 squared minus 4 times negative 3 times 4. And that is 64. Positive. So if you think about it, this would be 16, right? This gives you 4 times 4 is 16, right? Times 3 is 48. And then the double negative turns into a positive. So 48 plus another 16 is 64. Okay. So that'd be over negative 6, right? 2 times negative 3 is negative 6. And at this moment, once you've cleaned up the root and the denominator, like you basically cleaned up everything, got rid of all the brackets, that's when you can branch off and say that the first x-intercept, and we know there's going to be 2 because it's positive, okay? You go 4 plus square root of 64. Don't worry about exact values. We don't need to. Sometimes they'll ask you for exact values. We don't really worry about that. We just get it as a decimal. And then the second option that we're going to get here is x2 is going to be 4 minus square root of 64 over negative 6. And I'll show you how to type it in because I always assume, but it's not safe to assume, that you know how to use it, right? Watch how I do this. 4 plus second x2 to get the square root, 64. At this point, I hit enter. And then I go divided by negative 6. Don't forget to divide. I see a lot of students just go, oh, the answer is 12, right? And this would actually be negative 2. So you have found that the first x-intercept is negative 2. So it's negative 2, 0. That's the first x-intercept. So let's put a comma there. Right, therefore it's negative 2, 0. And this makes it a little easier to do the second one, right? Because you just scroll up and copy that entry and replace the plus with a minus hit enter, then go divided by -6, and that'd be 0.67 positive. Okay, so that's how you use your calculator. Okay, so don't type it in one shot because I'll show you what happens. Okay, just warning you, right? If you go divided by -6 like this, all in one shot, you're not going to get 0.67. Okay, what is happening here? It's applying bed mass. It's going to divide these two, and then that answer will be subtracted from 4, right? So you got to be careful that you're entering the proper information there. Okay, B. That would be a little. This should take you back to IPR. And here what you do is, right, this here is going to distribute across that. That's the first thing you do. You make sure you distribute and you basically expand it, right? You expand it. So 4x times x would be 4x squared. 4x times positive 3 would be 12x, right? So it's just the coefficients, just the numbers that multiply here, and the x tags along. Okay. -4 times x would be -4x. -4 times positive 4 would be -16. So expand first, right? Then we combine like terms. Actually, I'll just leave it like that because you should know what to do at this point. Don't want to say something later, it's not quite right. So anyways, you have 4x squared already here, and then you look at the other side, there's no x squared term anywhere. So you just leave it. Then you take the x term and you bring the x term that's on the other side over to this side. And the 16 comes over as well, and you make everything equal to 0 on the other side. Right? So these two basically came over adding. Both of them changed signs, right? And then you combine like terms. 4x squared, 12 and 4 is 16, plus 16 is equal to 0. Okay? So A is equal to 4, B is equal to 16, C is equal to 16. And I used examples that actually have nice round numbers for the most part. Okay. So there it is. This is just going to be -16. 16 is positive, right? Plus or minus 16 squared minus 4 times A times C, all over 2 times A. Another common mistake is that the 2A only affects the square root. It does not affect the first number. That's the other. Make sure this line goes right across, and then we branch off. X1 would be negative 16. We didn't quite branch off at that point, right, in the past. I wouldn't care, but I'll write the clean version here. So let's type this in here. So 16 squared and what do you get in here? I jumped the gun on this one. So I'm going to erase this. There it is. So because the discriminant is 0, therefore 1 x-intercept. So all we have to worry about is x is equal to negative 16 over 8, right? Because the 0, square root of 0 is just 0, so you end up with negative 16 over 8. And that's just negative 2. So negative 2, 0 is the only x-intercept there. And we'll do one more. So let's rewrite this. So that's what you get. Are you where I'm at right now? I haven't had Did you come across a negative discriminant while doing the homework at all? I'm not sure. So allow me to make a change. Otherwise, we won't have had an example. So go back to the top, make this positive. That 7 is positive, meaning you got to follow it and make it positive everywhere, because it stays on the left side the whole time. Okay, so that 7 is positive, so that means that in this formula it will also be positive. So it's just 7. Just a last minute executive decision. And now let's come up with that again, okay? You should get a negative 59 in there over 10. And at this point, right, is less than 0 or negative, right? You can say both. Therefore, no x-intercepts. Just state that, and then I know you understand what's happening. Grab your calculators, go y equals, and type this into y1. This part here when it's equal to 0. Because sometimes you will wonder, did I make a mistake or is it supposed to be this? Right? 5x squared plus 9x plus 7. So I'm going to have that show up here. And then hit graph. And there you can see, if you go zoom 6, it probably works, right? Right there. You can see that this parabola will never cross the x-axis, right? So it's confirmed. That's verified, okay? Now, before we leave, I'm going to show you an even easier way to solve these, okay? Okay, so second method, right? Solving a quadratic by graphing. You have two options here, right? Rewrite, two options here. Rewrite equation into standard form, right? Then enter into y1 and find x-intercepts. That's what you're used to doing, right? The second option you have is enter the left-hand side into y1, enter the right-hand side into y2, only report the x values of the intersections. Answer or answers should always be stated as x0, okay? That's important because the second method will actually give you a different y value, but you'll always state it as x, right? Whatever that x value will be, 0. Because remember, y is equal to 0 when you're finding the roots, okay? So we're going to give this a try right away. We just did that actually above. My favorite method, because it involves 0 rewriting, is this method right here, okay? So what we do is we enter this into y1, and we enter the right hand side into y2. Then we're going to go second, trace 5, and find intersections. Okay. So grab your calculator. And do that. So we're going to go 8x squared plus 5x plus 7, 3x squared minus 4x, like that, okay? So this goes into y1 and the right side goes into y2. Then hit graph. There's one. There's the other. And you're going to have to find the point where they cross each other, the intersections. We know, just to give you a prelude, we know that there are no x-intercepts, correct? We just did this one above and we got a negative discriminant, so there should not be an x-intercept. And that's verified by looking at these two graphs, they never cross. So let's increase our y max significantly. Let's go 1,000. Let's go to your y max, press in 1,000, and then hit graph again. It looks like it's crossing here, so we will investigate. We'll just go zoom in, and we're going to take our cursor right to where we think it's happening and hit enter. We're still not sure, so we're going to keep increasing that. And there you can see it's never crossing. That would be the only possible way where it could be crossing. So this is an example of lines never cross, therefore no solution or no x-intercepts. So this is doing the same thing as the quadratic formula. It's just a different way of doing that. It's using your calculator to graphically look at this and be like, wait a minute, they're never crossing, right? So what we could do, so this is one method of doing it, and the other one would be rewriting it. Okay, so I will do both on the next example here. And you already have the homework, okay? Let me just take one more. I'll do one more. That's it, as simple as that. It could also happen, right? You're like, what? What is this, right? So if you type this in to y1, and this, by the way, all you would have to do to show your work. Let's see if these lines will cross. So we type in 5x squared minus 4x. Okay. And into y2, you just type in 16, which we know is going to be a horizontal line. Okay. So we hit graph, and our graph is still set up for the old. Like, let's do a zoom 6. There it is. And we're not seeing it because y equals 16 is higher up. So window y max will go 20. There it is. Okay, so I explained to you what's happening here. You have two x-intercepts. You're like, they're not on the x-axis, Mr. Dirksen. I know. Just trust me right now. Just, there are two because these lines are crossing twice. So we're going to go second trace 5, enter, enter, enter. So it's, the first one is negative 1.43. Watch this. Do not write down 16. Only report the x values of the intersection. So we're going to go 0. And then we're going to go ahead and find a second intersection. Second trace 5. Enter, enter, enter. That's 2.230. These are your two x-intercepts. These are your two roots, right? Roots, x-intercepts, solutions, all the same. Hold on, hold on. I know I told you it's going to give you some time. This is first method. So this is graphing, okay? You can do it this way. You can do it this way, the way I just showed you, or rewrite. This one, some students still prefer this method for some reason. That's okay. There's nothing wrong with you, okay? So 5x squared minus 4x, we bring the 16 over to this side, which will change its sign, and then it looks like this. And then what we do is, right, this goes into y1, and this goes into y2, which you should recognize as finding the x-intercept. I don't know if it doesn't ring a bell, it will soon. So 5x squared, do it with me, negative 4x minus 16, y2 is equal to 0. Remember, that's how you find your x-intercepts. Hit graph, and there it is. Now you would say that looks like x-intercepts, right? So then you go second trace 5, just like before. And let's find them. Second trace 5. Let's see if we see something peculiar about this. What do I get for my answer? Exactly the same as I did before. Okay? Except for y is already equal to 0 here. And I'm not going to find this, well, I should show you, otherwise you won't believe me, right? This better be 2.23, and it is 2.23. Okay? And so using that method or this method, that's how you do it by graphing, okay? So I'm going to stop here. If you're online, you can sign off. I will post the answer key to the quiz in a bit. Yeah, you too. Okay, I recorded it, Yuvrach, okay? I'm going to post it in a bit.